Hello, everybody, and good afternoon to those who have joined us. It's a pleasure to be speaking with you all today. My name is Olivia, and I'm the Communications Coordinator with the Ontario Woodlot Association. Today, we're joined by Dr. Anne Koven of the Mass Timber Institute, as well as OWA and Kawartha Land Trust staff member Elliott Groen, and Ontario Woodlot Association Program Coordinator Glen Prevost. Before we get started, I'm just going to read a land acknowledgement, and then we will go into a couple of the housekeeping items, just so everybody is on the same page. So without further ado, the OWA acknowledges that we are gathered on shared traditional lands of the Indigenous peoples of Turtle Island. Long before today, there has always been Indigenous peoples, and they are the original stewards of this land. We are grateful for the opportunity to live, work, and play here. We offer thanks and honor all of the generations of peoples before us who have survived and thrived here since time long past. This land continues to serve as a meeting place and crossroads for peoples of many nations. Our recognition for the contributions and importance of Indigenous peoples is part of our collective commitment to make truth and reconciliation real in our communities as we strive for a harmonious shared future. I'll just quickly go over a few housekeeping items, and then I will get started with introductions. So just so everybody is aware, everybody who's attending the webinar, aside from our panelists and speakers, their microphone is muted. So your microphone is muted as well as your camera. We are recording this presentation to view later, and there will be a Q&A time at the end of the presentation. If you would prefer to raise your hand to ask your question, that's more than welcome. You can do so during the Q&A period, and we'll call on you if we have time at the end. Now I will stop sharing and introduce our first speaker for today, Dr. Anne Koven. Anne has spent more than 30 years working in government and business, primarily in the areas of environmental resource management. Anne is adjunct professor at the University of Toronto's John H. Daniels Faculty of Architecture, Landscape and Design with an interest in forest policy. She teaches Masters of Forest Conservation students within the Daniels Institute of Forestry and Conservation, and coordinated the accreditation of the Master of Forest program by the Canadian Forest Accreditation Board. Anne has been awarded with the Honorary Registered Professional Forester designation by the Ontario Professional Foresters Association, as well as the Bailey Award for making significant contributions to the profession and practice of professional forestry in Ontario. She is joining us today as the founding director of the Mass Timber Institute, which aims to help position Canada as a global leader in sustainable timber research and education, development, and export. Welcome, Anne, and thank you for joining us today.
Thank you very much, Olivia. I'm thrilled to be here, actually. I feel it's like a homecoming for me. I was for years a member of and the volunteer president of the Ontario Forestry Association, our sister organization to the Ontario Woodlot Association. And so I spent a lot of time visiting OWA members, going to their woodlots in the Ottawa Valley, the townships between Cornwall and Cobourg, you know, weekend and full-time residents in the Creemore area and beautiful forest lands, private forest lands around Lake Huron. So I'm pretty familiar with the membership of the OWA and have a great deal of respect for what private woodlot owners, private forest owners do by way of being stewards of clean air, clean water, and biodiversity for those of us who live in the city, or as my friends outside Toronto would call the city-state of Toronto, which tends to the stewardship contribution to the quality of life we have here in our environment is very much unrecognized in big cities. And I'm happy to be invited here today to share some of my observations about the mass timber developments going on and how I think there is a role for private woodlot owners, private forest owners, such as the OWA members, to be part of the supply chain for mass timber. And I know that Elliott and Glen will be following me to talk about the project the Mass Timber Institute is doing with the OWA, which involves exploring whether we can use the red pine many of you have growing on your properties to make mass timber products. And I will leave it to Elliott and Glen to delve into that. My perspective on mass timber, because I'm a forester, more academic than boots on the ground, but my perspective differs from architects, designers, engineers, and the construction industry, who are the end users of mass timber. I quickly recall that I was invited in 2018, 2019 by the Ministry of Natural Resources to start a Mass Timber Institute at the University of Toronto. We were then the Faculty of Forestry. We merged in 2022 with the Daniels Faculty of Architecture, Landscape, and Design, which is, of course, a particularly good fit for the Institute. I invite you to visit our website. We do podcasts on mass timber. We have a newsletter you're welcome to subscribe to for free, which I think can keep OWA members very up to date on what this thing called the mass timber sector is. We also have a number of other projects and resources. Professor Ted Kessick wrote the primer on mass timber, which is available on our website. He is teaching one of 2 or 3 courses now being taught at University of Toronto on mass timber and wood, which wasn't happening before. We've done research with the CRIBE, the Center for Research on the Bioeconomy, with one of our associates, Professor Razul Yusufpour. We've recently finished a study by Kelly Doran, a professor at Daniels, and his colleagues at the Half Climate Design consulting company, comparing carbon and costs between mass timber, steel, and concrete buildings, which of course is a very pressing interest to us all. So very quickly, what is mass timber? Mass timber is structural wood. There are different kinds of mass timber products. I'm showing you a diagram of some of the products that are most well known, cross-laminated timber being one of them, panel products, different laminated timbers, including glulam, laminated veneer lumber, and strand lumber. These products were originally pioneered in Europe, and you will hear from people talking about mass timber that some of the early ideas from mass timber certainly came from Austria and Germany. We've been working on mass timber in Canada for at least 20 years, if not longer. And I think there's a feeling that certainly we're making some progress in the adaptation of mass timber products and building technologies. Not as quickly as some would like, and we'll explore that as we go along. Page. I wanted to share with you some of the reasons why I am so committed to mass timber, and I think you'll share some of them with me, knowing as I do what your interests are and your passions as OWA members and woodlots. The first are the environmental benefits of mass timber. They certainly, and here I've very quickly indicated what I see those as being very compelling reasons. They lock in more carbon than steel or concrete. They have decreased emissions associated with them. The potential for reuse is enormous. And renewable sourcing. And by renewable sourcing, of course, those of us who understand forests and manage forests understand sustainable forest management. And It's exciting to talk to OWA members because I don't have to go into much description. When I talk about sustainable forest management, you understand very much what I'm talking about. Most of your properties are operated under a managed forest tax incentive program, which requires you to do responsible forest management for conservation purposes or for some commercial purposes. Another reason that I find mass timber to be a compelling new use of wood is that we've really lost a lot of ground in Ontario when it comes to the forest industry. When I started in forestry in 1988, I was chairing a very large timber management environmental assessment on Crown lands in Ontario. And when I started that project, you can see we had hundreds of sawmills. We're over 600. We're now down to maybe 86. We had a number of pulp and paper mills. We're now down to maybe 3 or 4. We had a number of veneer and panel board mills, and we're now down to 6 and 7. So the number of enterprises in the Ontario landscape with respect to forestry has really declined. And for those of us who are foresters or forest owners, or conservationists, environmentalists interested in what we're going to do with our forests, there has been a huge change in the Ontario mill landscape, which requires a reimagining on our part about what is the best end use for our wood. And as we know from sustainable forest management processes, we have the most expensive, highly regulated sustainable forest management legislative scheme globally. Anyone in the forest industry will complain and tell you about how difficult it is and challenging to conduct forest operations in Ontario, and that's something that's both challenging but also something we can be proud of. So I come to the conclusion that we have wood, and what is the best value for the wood that is available for us. And that leads me to the conclusion that we need to have higher value for our wood. We sell millions of board feet of wood annually, softwood lumber, to the United States from Ontario. Of course, the bigger producers are Quebec and British Columbia. Recall that Ontario is 3 or 4 by way of a forestry province in Canada. Also, because we have a rich economy in Ontario, the value of our forest industry is well below 1% of GDP. So forestry is seen as being a small industry and a regional industry by way of larger forest operations. In my view, we need to be able to add value to wood because I think we're all very interested in pushing the supply chain and the value of the supply chain into regional economies. I don't see why we would need to keep the value of wood in Toronto area or in only 1 or 2 mill towns. I think that mass timber promises smaller to medium-sized mill infrastructure that can be built in urban, in rural areas. We don't need the old kind of pulp and paper mill that required hundreds of millions of dollars of investment to make mass timber products. And we know that mass timber product has 7 times the value of lumber. And I was trying to do a calculation of what that is. And today, a 2x4 of Eastern spruce pine fir is priced at about $625 per 1,000 board feet. That would have an equivalent value of $4,375 in a mass timber product. That's a very simple calculation, but I'm only pointing out that I think the sustainability factor of using our wood for mass timber produces an enormous amount of value that can actually be made available to regional economies and perhaps to private woodland owners to do improved forest management on their own lands. And of course, the larger value debate that we've never solved in this country is that we haven't been able to achieve the amount of value added in forestry products or mining or other extractive resources that we would like. And I think mass timber really does provide the opportunity for that, and will certainly, I think, help push us above what Harold Innes, a political economist at U of T, called our Staples trap, and the label we continue to receive as hewers and drawers, hewers of wood and drawers of water. One observation that I've had about the mass timber sector, and again, I'm sitting here at the University of Toronto in downtown Toronto, but that there is a great deal of, there has been, certainly for the last 5 or 6 years, a great deal of excitement about mass timber, but I would describe it as a bit frothy. I see lots of plans for mass timber buildings. I see many fewer mass timber buildings being built than I think the publicity suggests is happening. This is one map of mass timber projects in Canada. They're talking about, this is a map that by Natural Resources Canada that have somehow arrived at the number of 832 mass timber projects having been completed, planned, or currently under construction in Canada in 2024. I don't believe these numbers. A lot of these planned projects have been stalled and put on hold. So I certainly urge people to understand that we're at the very beginning of a mass timber industry in Canada, and to always look behind the numbers that you're seeing. By way of the United States, sorry, I'm having trouble with my slides here. In the United States, the Woodworks Innovation Network is claiming 951 projects in North America, as well as one in the state of Hawaii. So I think that we're at odds here with respect to the desire to plan to build a mass timber project and what actually ends up on the ground. We have some wonderful examples of mass timber buildings in Toronto, and I will get to that in just a minute. Here is the first one. This is at 80 Atlantic Avenue, one of our first mass timber buildings in Toronto. A very beautiful 5-story building. I always refer to this building, as I do to the Art Gallery of Ontario, which has gorgeous mass timber beams, as selling itself on the aesthetics. People are very excited to live and work in wood buildings. A new building going up at the University of Toronto at Trinity College. It's the Lawson Center for Sustainability. They're up to about 3 stories. You can walk along Philosopher's Walk and see the building. It's behind Trinity College and coming up close to the athletic center. And certainly this building is it takes a lot. It's going to be both a classroom and a workspace and some other student facilities. And certainly I think the universities and colleges have really been in the forefront of innovating with mass timber for the reasons we talked about, particularly the climate-driven benefits of using mass timber, substituting a little bit of the regular construction, traditional construction projects with mass timber. And certainly There was leadership provided at the University of British Columbia with first student mass timber student residents there, and that's continuing. And I think these demonstration projects are very, very important to understand what's happening. This is the infamous U of T's tall academic wood tower that's going up at 150 Devonshire. I was at one of the first meetings where we discussed building a mass timber building at U of T. That must have been back in 2013, 2014. It's just being built now, so you can understand the amount of time it takes to plan to build a mass timber building and actually get it built. This is the Limberlost Place at George Brown College, a gorgeous development sitting on the lakeshore near Cherry Beach. And again, the idea that we have universities and colleges who are really leading the charge on mass timber developments. T3 Bayside. This is a lovely building, again, on the lakeshore, east end of Toronto near Parliament, which is one of the largest commercial buildings. This is the phase 1 building. There will be a phase 2 starting. It was completed last fall, and really is a commercial building and one of the largest in Canada. The developers was built by Easter Construction, and it's really a remarkable example of beautiful architecture and design. Before I leave my slides, I wanted to talk about just a few of the challenges that mass timber is facing, and I think they can be in 2 categories. And these are very top level observations. The first one is that we don't have a strategy in Canada for building with mass timber. We have competition among the provinces. We have very small funding from the federal government. And as a result, I think we get mired down a bit in really what we could be doing much more. There simply is no strategic application going on. Certainly, Toronto is obviously a major construction center in the country. And of course, we are doing what we can to advocate and promote mass timber, but I think we need a national strategy. And I would certainly, at the risk of having my wrist slapped, I would put a lot of the responsibility on the federal government for not paying more attention to the opportunity Canada has to really be a world leader in mass timber construction and supply chains. And the second point I would make is that the supply chains are very wobbly. We still import mass timber products, mass timber from Austria to construct mass timber buildings in Toronto. It always comes as a shock. We have so much wood in this country and this province. How could we possibly be doing that? But we are. And the longer term specter that concerns me greatly is we continue to sell a lot of softwood lumber to the United States, which is a good thing. But we will be buying mass timber products from US manufacturers using our wood. We will be buying those products. And that's a kind of sad Canadian story that's been going on for hundreds of years. So certainly in a bigger picture, I see us as really, really needing to work harder at developing efficient supply chains. So I think I've used up my 15 minutes, Olivia. I didn't look at the clock, but I'm really happy to talk more about what the Mass Timber Institute does. I'm happy to talk about what I see the future of mass timber being, and I guess there's an opportunity at the end of the session for questions. Thanks very much.
Thanks so much, Anne. I think folks are going to have a lot of questions, and it's such a vast topic with so much development happening. It's quite exciting. In the chat there, I just put the link to the Mass Timber Institute's website so folks can check out the webpage and also the podcast. We also, for folks who have just joined us in the last 20 minutes, we're up to about 50 participants now, and anyone who missed the housekeeping items, there is a Q&A box at the bottom of the screen. You can put any questions that you have throughout the webinar today in that Q&A box, and we'll address as many of them as we can at the end. I'll now introduce our next speaker, Elliott Groen, who is the Sustainable Forestry Coordinator with the Ontario Woodlot Association and Kawartha Land Trust. Elliott is a registered professional forester in training with Scope and a graduate of the Sir Sanford Fleming Forest Tech program with the Indigenous designation perspective. One of Elliott's ongoing projects with the OWA and KLT is the Forest Owners Cooperatives, which assists woodlot owners with silvicultural thinnings of plantations that are overdue for active management. His talk will cover the initial project progress tracking, the wood from plantations in need of management, engineering, testing, and planned end products. I will hand it over to you, Elliott. And you'll just need to unmute yourself.
That always helps. Okay, everybody can see my screen good?
Yes.
Okay, yeah, good afternoon, everybody. Good to see many familiar names in the participant list there. There we go. So yeah, like Olivia said, I'm going to talk a little bit how we've sourced some red pine from thinnings in our members' woodlots, the physical testing that's been happening at the Mass Timber Institute of this red pine, and then what our plans are to use that cross-laminated timber for in an accessible warming hut in one of our community forests. And all of this fits within a sustainable forest management framework. We're covering off that ecology by doing silvicultural thinnings to increase biological and structural diversity in woodlots. We're covering the economics by exploring these new uses and markets for red pine, and then providing some social benefits as well on publicly accessible trails. And shout out to our partners, Ontario Ministry of Natural Resources and Forestry, Mass Timber Institute, Kawartha Land Trust, Ontario Power Generation, and Koven. All right, so that picture, it's what a lot of red pine plantations look like. Buckthorn, dog strangling vine in the understory, and wood that is either just at or just below the size where it could actually be sawed up into 2x4s. So for the red pine for this cross-laminated timber project, we got that from one of our member woodlots in the Kawarthas. And like Olivia said, the aim of that Forest Owners Cooperative project is to provide an affordable means for landowners to take care of their forests. And the initial scope of it has been to facilitate silviculture, including thinning, invasive species control, if needed, some underplanting in degrading plantations. So the one that we sourced the wood from, it was a second thinning. The first thinning only cut rows. There wasn't any selection in between. 8-acre stand. On average, we got just over 10 cords an acre. The diameter of the trees ranged from 16 to 28 centimeters, those smaller trees being the ones that were more in the rows that did not get thinned. Was cut and hauled by Magoo's Transport, and then milled and planed by Brower Wood up in Keswick. And this is what one of those thinnings looks like from inside the cab. So this particular tree, you can see we're getting 4 8-foot sections out of it, down to around 5 inches at the top diameter. And on the left here, I took these pictures at dawn. This particular site is on my route to the office, so as I was getting there at sunrise. Yeah, this is what it looks like post-thinning. On the right, you see some of the stacked wood waiting to be hauled. Okay, so that wood was sawn up and planed into 2x4s and delivered to the Mass Timber Institute. Tony Ung has been working on it there, so thank you to him for providing these preliminary results. And all of the testing has been following the American Society for Testing and Material Standards. And there's 3 basic metrics that we've been looking at: the modulus of rupture, when does the wood break; the modulus of elasticity, how far does it bend before coming back; and then the compression parallel to the grain, which is measuring how it breaks when force is applied to it in that vertical plane, like a stud versus a beam. And yeah, you can see here in this picture, this is a lot of the wood is from the center of the tree. You can almost start to see the pith in some of those bottom pieces, and the growth rate is pretty fast, about 0.3 centimeters a year. So first step of what Tony did is he did a 4-day drying regime in the kiln to reduce the moisture content from 35 to about 8 to 10%. While this was occurring, there was significant warping and cupping, especially from the pieces that were closer to the pith. And all of these samples were compared to US grown and Canadian grown red pine, for which these physical testing have already been done. So here's just some pictures of the twisting and bowing of the wood. All right, and our first test. So this one tests the modulus of elasticity. Basically, you put weight on it. At the bottom there, it measures how much it bends. And you can see here, first line is the US grown red pine, second line is the Canadian red pine, and then that third line that says CLT RP, 10% moisture content. That is what we got from this particular 2x4. And you can see it's significantly less elastic compared to the published results. Next test, modulus of rupture. Basically, how much force can we apply before it breaks? And again, this red pine, significantly less, about 24% less strength. And then the final test is breaking it parallel to the grain. Not as much of a difference here, only about 3% lower than the published results. So all 3 tests on juvenile wood came back with significantly or marginally lower values compared to other tested red pine. But this is why we're testing it in cross-laminated timber and glue-laminated timbers to see if this wood that normally goes towards fencing, decking, still lasts for 15 years or so, if that can have a longer life in bigger load-bearing structures. So next step is Tony's been fabricating. You can see here in this picture, the cross-laminated timber samples. And then he's going to do some more testing. This next one that's set up here is a 4-point bend fixture test to determine at how much force the cross-laminated timber will break. And what we're planning on doing this, once we have the engineering specs back, is exploring the long-term market for cross-laminated timber from this juvenile plantation wood. And we're going to do that through constructing an accessible and all-season shelter at the community-owned Limerick Forest, which is in Oxford Station, about halfway in between Kingston and Ottawa. They're one of our FSC certified forests. And it's going to be an accessible shelter in that it will be wheelchair accessible and part of a trail that they've got set up for that as well. There's going to be 6 solar panels on it. And the intent is for it to be a place to rest, plan your hike, have a meal, get out of any bad weather, and then also provide an opportunity to add to the interpretive trail that's already in existence at the Limerick Forest. So my last slide here, estimated budget is $44,000, and that includes payments to the landowner for the wood, harvesting contractor, the fabrication of the cross-laminated timber, solar panels, transportation to the site prep, assembly. It's 107 square feet is the layout. So quick math, around $400 a square foot. Pretty expensive. But this is a test. We're seeing if it works, and the costs would be less for larger buildings, as a lot of these are fixed costs. So we'll leave discussions and questions to the end. That's what I had for today. Thank you.
Awesome. Thanks so much, Elliott. That was a great follow-up to Anne's presentation to see kind of the steps that it takes to take a product from design to execution, hopefully. So next up, we have Glen Prevost, who is the Program Manager with the Ontario Woodlot Association and Eastern Ontario Model Forest. Glen is both a registered professional forester and a professional engineer. He has a Master in Forest Conservation degree from the University of Toronto and a Master of Applied Science degree in Civil Engineering from McMaster University. He is also a Managed Forest Plan Approver under the Managed Forest Tax Incentive Program, MIFTIP. And under Glen's leadership, the Forest Certification Program continues to grow and expand. I will hand it over to you, Glen.
Thanks a lot, Olivia. All right, I'll get going here. All good there, Olivia?
All good.
All right. So I'm going to dust off some old work that I did when I used to work for FP Innovations, and we wrote a case study of an engineered wood bridge at the Petawawa Research Forest. So Livy, you already kind of gave an update, just so people know I'm located in North Bay and travel all over visiting folks, but that's where my home base is in North Bay here. So the Petawawa Research Forest is the oldest research forest in Canada, and it's managed by Natural Resources Canada through the Canadian Wood Fibre Centre. Several years ago, around 2017, 2018, a culvert failed on Youngs Creek along a road called Meridian Road. And it's a fairly significant road within the research forest. It's used for accessing different research sites, accessing different harvest sites, and also used for recreation. And some dedicated PRF staff made the case that a timber bridge would be an appropriate structure to replace the culvert that was there. I think it's a pretty strong argument that was made that this is a research forest, and so within the spirit of demonstration, a timber bridge should be built. It was the first one that had been built for forest access and generally in Ontario for many, many, many years. Since then, there's been a few more. Actually, one here in North Bay, not too far from my house, but this predates the one on Youngs Creek here predates that one here in North Bay. And the idea is that the forest industry could use its products, in construction of forest access, so that they can get into the forest using their own products. So the result, we went from this to this, which I think is a pretty massive improvement. It's a lovely bridge, and this is the cover from the case study that we put together, looking at the construction of it, looking at who was involved, looking at costs, and I'll run through all of that. Okay, make that smaller. So there were a number of different engineered wood products and non-engineered wood products used in the construction of the bridge. So it was just standard dimensional timbers and heavy timbers. So the vertical boards, the vertical timbers here using the guardrail, those were just sawn timber, as was the crib here at the end. And then you've got wear boards on the surface. So those are I think they were 2x6 or 2x8s, and they just go on the surface and can be replaced from time to time as vehicle traffic wears them out. Underneath, you've got nail laminated timber. That is the decking. So that's the lateral support, or the horizontal support. And then you've got glue laminated timber. There's 5 large glue lam beams underneath supporting the whole structure, and those are called girders. So the folks involved, Pete Arbor deserves most of the credit for making this bridge happen. He willed it into existence. I know John Pino, when he worked at FP Innovations, really prodded Pete and argued that he should do it. But after it got going, Pete was the one who really made it happen. The structural engineer was WSP out of Ottawa. Corrington Engineering was the general contractor for the site. They're based in Renfrew County. And I guess I should have said that the Petawawa Research Forest is located in Petawawa, or just outside of Petawawa, which is in Renfrew County. And then Timberman Timber Works, timber construction company just outside of Barrie, was the one that did the timber installation, supplied all the woods and the construction drawings. They made the nail laminated timber, and they remanufactured the glue lam and did a bunch of the wood treatment as well. And just quickly, the main components were there were 5 large glue lam girders that you could see there, the 10 by 10 inch timber cribs, and the nail laminated deck. I will note that these timbers are so large because, not because it's wood and it's not very strong, but because there was an elevated standard that the bridge had to meet, because the Petawawa Research Forest is located at Garrison, Petawawa. It had to meet a standard for military use, because sometimes military vehicles would be driving over it. So this is what construction of the different components looks like. All of these pictures, except for the glue lam press up in the top left, are actual photos of the construction of the bridge. So this is how glue lam's made. You can see it up in the top left. It's put in a press, just dimensional lumber pressed together with glue. These 2 pictures on the top right, middle and top right, that's a nail laminated timber jig that is used for what was used for making the decks, and Timberman Timber Works produced and manufactured those decks at their site outside of Barrie. They also cut and bolted together the cribs. Again, this is at their site, and then they were then transported to the build site from there. Construction on the site, pretty standard for bridge construction. There's some riprap there to stop erosion and sediment from getting into the water. There was a diversion of the creek. There was some dewatering. You can see here, this is where the cribs were going to go. So they had to pump the water out, lay some aggregate in the bottom. And then finally the cribs become installed on, this is just one end, and obviously there'd be another on the other. And then the construction process, using cranes to lift the different components into place. I think it's amazing that they have these huge, very rigid construction components, and then they can use these little brackets and they get it right on the bolt hole. I think that's pretty amazing. You can see there's blue skin on top of the girders, and that's to stop water from resting and sitting on top of the glue lam, causing, just helping to resist rot. You can see the nail laminated timber decks along with the wear boards, and then finally completion of the bridge at different stages. So how does this compare to a standard forest access bridge? Well, the top left, that's the Centennial Bridge at the Petawawa Research Forest. The bottom right is a standard forest access bridge using standard Ministry of Natural Resources designs for bridges constructed on Crown land. And I won't mince words. The Centennial Bridge looks a lot nicer than the steel-based bridge. The steel one, utilitarian, works fine, but it's not all that nice. And so you can see where, especially in certain applications where maybe there's a high recreational use, maybe there's a lot of traffic over the bridge, where you might want to, just purely for aesthetic reasons, never mind all the other benefits, put in a timber bridge. Just fits in with the landscape a lot nicer than this industrial looking utilitarian bridge. So obviously people are going to want to know about costs. And so this was a really challenging exercise to try and figure out the costs. And the reason was that the Centennial Bridge was built on federal land, and it kicked in a whole bunch of environmental assessment processes and government procurement processes that just drive up the cost. But I was able to get down to it. And so for the main components, the glue lam girders, for the very similar cost, maybe a little bit more at shorter lengths, but you get up to longer lengths and you're looking at very similar costs. The cribs on both bridges, while they were different, they were both made out of heavy timbers. And so really it doesn't matter which one you use. You could come to a a design that worked and was economical. So they both use timber there, so that's good. The decking, Centennial Bridge used nail laminated timber, while the Ministry of Natural Resources uses 8x8 timbers. And designers could choose one or the other. Again, it's both different, but both wood, so that's great. The engineering and design costs, for if this bridge, the Centennial Bridge, had been constructed out of steel and concrete, the engineering design would have been more expensive. Now, that doesn't mean that the design of this bridge was less expensive than the standard Ministry of Natural Resources bridge, but that's because the Ministry of Natural Resources has standard drawings that all their bridges can be drawn to. And so a similar thing could be done for forest access bridges like the Centennial Bridge to be made out of timber. You could have standard drawings that would dramatically lower design costs. And then in terms of lifespan, 40 years would be standard. The glulam bridge could be refurbished after 40 years. The girders should be fine, and some of the other components would just need to be replaced with a life up to 60 years. And there were many places where where it was quite similar. So the load capacity was very, very similar. Hardware protection, they both use galvanized fasteners. They both required standard wood protection, pressure treated and other end cut preservatives. The wearing boards on top, very similar. They both use Douglas fir. You could use local species. In this case, I think, Anne got to the heart of it. It can be hard to find locally produced engineered wood products, and that was the case here. The bridge delivery equipment, float costs, lead time, and people needed to construct it they're almost exactly the same. I interviewed different people who had built standard bridges as well as this current bridge, and it was very similar. So you can use all the same folks and all the same equipment and come out with just a nicer looking bridge. So that's it. If anybody wants to go see it, it's open to the public. You can go to Meridian Road at the Petawawa Research Forest and have a look at the bridge. And Olivia, that's what I've got.
Awesome. Thanks so much, Glenn. So I suppose we're winding down now. I'll just invite the speakers, and Glenn and Elliott, if you have anything final you'd like to add, and we can begin to wrap things up.
No, I don't. I've just been really just thrilled to be a part of an OWA event, and also to thank the OWA for hosting our students. I take a group of Master of Forest Conservation students from U of T every year to Mattawa for a winter field camp. So thank you, OWA members, for giving my students that opportunity.
I'll speak up and say I think it's a real pleasure. I know that OWA staff look forward to it each and every year, and I know CIF is heavily involved with it as well, and Petawawa Research Force, and I'm sure many other who I haven't mentioned at the moment. But thank you again, Anne. Thank you, Glenn and Elliott. It's been great to be able to offer a talk about mass timber, and we look forward to doing it again in the future. So thank you, folks. Have a great rest of your afternoon, and we'll be in touch.
Thanks,
Bye,
Olivia.
everybody.
Bye.